Okay, so now that we have it in terms of u, all right, we can take this integral fairly easily. So you can really think of the 1/2 as out in front of everything. Times. Now we use your anti-power rule. U to the 6th all over 6 plus c. Is that right? Mm-hmm. Okay, and so now I'm just going to say, kind of my next step down here, it's all over 12, because 2 times 6 is 12. Yeah, the du just goes away when you take the integral. All right, and then u to the 6th actually is what?
6x squared minus 1.
So what is u?
X squared minus 1?
Yeah, x squared minus 1. So that's your answer for the integral. So we just use... All right, so we set our u equal to 3x minus 2 du dx, which is just the derivative of u is just 3. All right, 3 over 1. So when you flip this, dx over du equals 1 over 3, multiplied by du, so that just brings it up over here, right? So your integral turns into u to the 4th times 1 over 3 du. All right? So what is that? 1 over 3 times u to the 5th over 5 plus c. And all that's 3 times 5 is 15. U is 3x minus 2. Look at that.
I forgot my C.
Okay? Don't forget your C. Got to wear the scarf. The vitamin C scarf. Okay? So, with square root, okay, treat the stuff under the radical as the parentheses. So we're going to let u equal 5x plus 4. Now, that makes it easy to take the derivative. We're trying to make it as easy as possible to take the derivative of u. If you have a u and it's a difficult derivative, probably not going to be the correct u to pick. Okay? So this is 5 over 1. So when you flip it, 1 over 5 du. Okay? So, here goes my substitution part. I have the square root of u times 1 over 5 du. Okay? The square root of u is actually u to the 1/2 power. Okay, and I'm just gonna take my 1/5 out front, because you can do that as well. Just bring it all the way out, and it kind of simplifies your integral a little bit. So now we're gonna use anti-power rule. So you have 1 over 5 times u to the 1/2 plus 1 is 3/2 all over 3/2. Okay. Plus c. All right. Now what you got to do is you got to get rid of this fraction in the bottom. You really do that by multiplying by 2 over 3. Okay. So that's kind of how I did it the easiest way there. So what do we get? We get 2 u to the 3/2. U happens to be 5x plus 4. All right, all over 15 plus c. All right, let's look at number 3. So the first thing you got to do is you got to pick your u. Pick it wisely. Okay, it's usually what's in parentheses. 6x minus 1. Got some singers in the building today. Okay. Du over dx. So I'm trying to take the derivative of u with respect to x, which is 6 over 1. So I'll flip it.
Yeah, 1/6 to the du.
Why you didn't? Hold on. Why you didn't? I got
It's right here. So now we have everything that we need to substitute. Okay? So I'm just going to rewrite. I've got 4 parentheses u to the 2/3 power. Now dx becomes 1 over 6 du. Okay? So if I multiply this constant through to the 1 right here, we have a 4/6 out front of everything. Okay? Can I go ahead and simplify that 4/6 to be 2/3?
And you can.
Okay, so I'm going to do that. So right now I have 2/3 and then the integral of u to the 2/3 power du. Okay? So I have all that taken care of.
Hey, headache.
All right? Now I'm able to use my anti-power rule where I do 2/3 times u to the 2/3 plus 1. So think about what's 2/3 plus 1. That's 3 over 3, which is 5/3.
That's crazy.
Okay, and all that's over 5/3. So because of the same concept, I'm just going to write it out. Okay, keep writing it out. The same concept, we're going to multiply by
5 over.
the reciprocal.
3 over 5.
So it's multiplied by 3 over 5. And then you have u to the 5/3 plus c. Okay? Now look, your 3's cancel. And this leaves you with a pretty nice answer, actually, of 2/5 parentheses, all right, whatever u was to the 5/3 plus c. Okay, so I'm just going to go back up into my original u statement. U was 6x minus 1, so that goes there.
Hold on, what is second? Oh, no.
Look what we got right here. Okay, so remember, I want to choose a u that is not hard to take the derivative of. So I don't want to take like to the fraction powers and do all that stuff. So I'm just going to let u be 2x squared minus 1. I'm going to pick that because I know it's going to be a nice derivative. So du dx, derivative of 2x squared is just 4x. Okay? 4x over 1. So now your dx is really 1 over 4x du. Okay? So we got that now. All right? Now I'm just going to rewrite my stuff. Okay? I'm going to rewrite. And again, y'all have this video to go back to. Okay? So I'm going to rewrite everything in terms of u. So I have x over the cubed root of u times dx substitutes to be 1 over 4x dx.
Du? I thought it was right.
Okay? Excuse me, du. You're right. Sorry about that. Now look, I have something nice that cancels. The x's magically cancel each other out. Magically. Okay? So, I'm going to bring my constant 1 over 4 out in front of my integral. Okay? And then I have 1 over the cubed root of u. Okay? Now that doesn't help us. We want to get this to be a power. Right? So I use what I know about powers. That's really u to the negative 1/3 power. Cube root of u in the bottom. That's a negative exponent. Negative 1 over 3. Okay, and that's du. So we go through and we do our integration. Okay, you keep your 1 over 4. That's multiplied by, you have u to the negative 1/3 plus 1, so that's what, 3 over 3? So u to the 2/3 all over 2/3 plus our c value. Okay? So that's actually, all right, 1 over 4 times 3 over 2 times u to the 2/3 plus c. Okay, and I'm running out of space. All right, so what is that here at the bottom right here? 3 over 8. We got 3 over 8 parentheses to the 2/3 plus c. And what is our u value? U is 2x squared. 2x squared minus 1. So it's 3 over 8 parentheses 2x squared minus 1 to the 2/3 power plus c. Okay, so 8 looks absolutely awful when I first look at it. Okay? But
Can't you choose either one?
we're going to choose, all right? We're going to choose wisely. Okay? Because all throughout our processes here, we had something that canceled out, right? So I'm going to choose the one that's going to give me a derivative with just an x in it. Okay? And that happens to be the thing under the radical. So I'm going to let u be x squared plus 4x minus 5. So now when I take its derivative, du dx, we have 2x plus 4, or excuse me, just 2x, right? No, 2x plus 4. You're right. Okay? 2x plus 4. All right? And that's over 1. So we do our usual deal where we flip it over. Okay? 1 over 2x plus 4 du. Well, I'm looking at that, and 2x plus 4 isn't going to cancel with x plus 2.
So you should have worked with the other one.
But could I take out a 2? Could I factor out a 2 in the bottom? So I could say 2 parentheses x plus 2 du. That's nice, isn't it? That's really, really nice. Okay, so now we're going to rewrite all our stuff here. All right. So we got x plus 2. Then I have the square root of u. Can I just say u to the 1/2 to save space? Bless you. Times 1 over 2x plus 2 du. Okay, so look what happens. Okay? So look what happens when we cancel the x plus 2's. Now I just have a derivative. All right. Of that. So when we take the integral of this, that gives you 1/2 times what, u to the 3/2 all over 3/2 plus c, and that will give me 1/2 times 2 over 3 u to the 3/2 plus c. Okay, so I have some stuff that cancels. The 2's cancel each other out. So that's what, 1 over 3 u to the 3/2 plus c. Okay, so I'm going to finally substitute back in for u. So I got 1 over 3. What's my u?
X squared plus 4
X squared plus 4x
x minus 5.
minus 5. We said that's to the 3/2 power
Yeah.
plus c. That would be your antiderivative right there. So on 7 looks like a doozy right here.
Yeah.
All right. So let's look at it.
So country.
So when in doubt, let's use what is in parentheses. So x to the 3/2 plus 4. That's going to be my u. Okay? So now I got to take the derivative of that. Du dx. So that's what? 3/2 x to the 1/2? Ah. I like what I see here. Okay? Which is really, can I do one little thing? Isn't that like the x to the 1/2 is in the top over 2? Okay, technically that x to the 1/2 is still in the top of a fraction. Okay, so I'm just going to rewrite it like that. It's going to help me when I flip it. Okay, so what happens when we flip this to get dx, solving for dx? Isn't that 2 over 3x to the 1/2? Du, right? So I think that's gonna help me immensely. Okay, good word. Immensely means a lot. All right. Tremendously. All right. I'm gonna substitute some stuff back in. Okay. You got u to the 9th power times 1 over 3x to the 1/2 power du. All right. That is just from substituting everything back in. So I substituted. Let me kind of color coordinate this for you guys. Dx is this piece. Okay.
Yeah, that's a 2.
Oh, sorry. There's a 2 up there.
Oh, that's what I'm trying to get.
Alright, we back on the same page.
Okay, that's a 2. Sorry. All right, now we're good. Okay. So look, what cancels here?
X to the 1/2.
Ah, that's beautiful that it cancels. Beautiful.
Left.
All right. Now, y'all quit making fun of each other.
Yeah.
All right. U to the 1/9 power du. Isn't that easy to take? Okay, so that's what? 2/3 u to the 10th over 10 plus c. So 2 over 30.
So
What's 2 over 30?
U to the 10th over 15.
1 over.
Yeah, 1 over 15. Then you got u to the 10th plus c. So what is that? That is
X to the
1 over 15th. And we said u is actually x to the 3/2 minus, or plus 4, sorry, to the 10th power plus c. Phew! Look at that one.